Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Problem 127 gives you some information about boron and asks a few different questions about it. So part 1 here says that boron has isotopes with 5 neutrons and 6 neutrons and gives you the relative abundances of each of those isotopes. So boron, if you look at the periodic table, has an atomic number of 5, which means that there are 5 protons in the nucleus of this atom. So remember that the mass number is the number of protons and the number of neutrons summed up. So the boron isotope with 5 neutrons then would be boron 10 because there are 5 protons and 5 neutrons. And the boron isotope with 6 neutrons would be, boron 11. So part 2 here asks you to draw 10 atoms and asks what the average mass of these atoms is. So I'm going to draw boron 10 as red and boron 11 is blue here. Now the problem tells you that boron 10, which has 5 neutrons, makes up about 20% of the total boron in nature. So if we were to draw 10 atoms then, that would mean that 2 of them, are this boron 10 here, and then 8 of them are boron 11 because they make up about 80% of naturally occurring boron. The average mass of the atoms here, of course, we would do a weighted mass, just like when calculating the atomic mass of a real scenario. 10 times 0.2 plus 11 times 0.8 gives us the weighted average or the mass of boron in this scenario when just looking at this drawing. So that would be 2 plus 8.8 here, or an overall atomic mass of 10.8. And then the last part of this question asks us to calculate the actual atomic mass of boron based on the actual mass of each of these isotopes, which is given in the problem, and in the percent relative abundance. So we can do the same thing as in the last part, just using real numbers instead of that little sketch that we drew. So boron 10 has a mass of 10.01294 atomic mass units, and its relative abundance is 19.8%. And then boron 11 here is 11.00931 atomic mass units, and its relative abundance is about 80.2% or 0.802. So what that gives us is 1.983 atomic mass units here, plus 8.829 atomic mass units. And if we present this in the proper number of significant figures, that gives us remarkably the same number as we saw from our sketch, 10.8 atomic mass units, which is the mass of boron.